Hello, everybody. It's 2 a.m. in Japan, but I already started my today's coding practice. So today's question is this one. Parkings are safe. I actually tried to solve this question a few hours ago, and I was knocked out. So I went to the dinner and I went to the barber shop to got my hair cut, and then after that I finally come back to my house, and I'm shooting this video again for this question. And I've already checked out the editorial of this question, and I've found that this question is super hard, quite tough. So this uses the kind of the graph algorithm. Yeah. So today I decided to solve this question is with just backtracking, which is quite standard way to solve this question, but it takes so much. I mean, the solution is actually TLE, yeah, time limit exceeded. But anyway, I will, but even in that way, I will finish the implementation tonight. Then tomorrow, I will implement the accepted solution with the graph algorithm. So that's what I will do for this question. Okay, so let me go with, yeah, let me get started. So in today's question, I will be given two integers, n and k, and my task is that, for example, if I get n is 3 and let me do with n is 2, k is 2, this means that, okay, we have a password in our mind, and if n is 2, which means that password has password is 2 digits. Then if k is 2, each digit is in range 0 to 1. So yeah, with n and k, the password is limited to those which meet these two conditions. For example, I could have 00011011. Then what I need to do in this question is I have to think of the sequence of digits which includes all of these digits, all of these possible passwords. So in this case, probably this has the shortest one because it has 00 here, 01 here, and 10 here, and 11 here. And I cannot make this such a sequence which consists of only 4 digits. Yeah, so this is what I should return. In this question, I will return the sequence itself, not the minimum length. Yeah. So, okay, that being said, yeah, with the, okay, I just clarified the question and also I've shown the example, so I will think of the algorithm. So, the, okay, so what I can use in this question is using the backtracking algorithm. So, I will choose think of every possible character. Yeah, I mean digits for each, position. And when I get 0, then I will get 0, 0 or 01. And then when I get 0, 0, 0, or 001 or 010, 011. Yeah. And what I can say from here is, for example, for this 000, there is no limit that I repeat this 00 and 00 twice. It completely just redundant, and there's no need that I continue 0 3 times here. And in the same way, let me think of this. If I get 0101, um, I found 01 firstly, but I then get 01 again. This is completely the waste of the digit because, I mean, there is no benefit for repeating 01 twice. I just can remove this one and I can get some maybe 0, yeah, here. In that way, I can find 00, which I have never seen. So that being said, my backtracking algorithm would be something like this. So I will keep track of the scene nums. Yeah. And also I will keep track of the current sequence. Here I will put digit I've ever seen. And then drag back, yeah. And the main method should be kind of, find mini, I mean, sequence method. I don't need any argument here because all I have to keep track of is, I mean, kept as these two shared variables across the functions, I mean, recursive functions. And the terminal condition of this should be when, yeah, if C nums count is enough, then I will update global show test seek or something. Yeah. And otherwise, I will keep track of choose one possible digit here, and then I will continue backtracking. I just have to make sure that I don't repeat the password, which is already included in scene nums. Okay, so that basically what I can do. I mean, yeah, for this question. Okay, so let me work on the implementation. But before that, let me quickly, estimate the time complexity and space complexity. So for time complexity, the time complexity should be n to the power of, no, k to the power of n, upper bound. Yeah, obviously I can finish the recursion um much earlier. For example, 0000 can happen. So time complexity should be smaller than or k to the power of n. And for space complexity, for the recursive function, I mean, for the recursion stack, it has to have k, no, n, because at max, the number of recursion should be exactly sorry, it should be nk upper bound because I have these passwords, and in the worst case, or I should say, at least I can say it can be longer than this. So yeah, that maximum length. Oh, but wait. So the first, okay, wait a minute. So this should be k to the power of n times um n. Yeah. So this is the upper bound. And also, yeah, so this is the maximum size of recursion stack. And also I have to think of C nums and current seek. And for C nums, this should be, yeah, at max, this should be k to the power of n numbers. And yeah, so this should be the maximum, size of the C nums. And for current seek, at max, this should have k to the power of n, No, k to the power of n times n. Yeah, right. Because current seek is at basically the same as number of recursion stack. Because yeah, I mean, when I put one more stack, recursion stack, which means that current seek is appended by one. Yeah, so this should be the upper bound of the space complexity. Okay, so I will start the implementation. In passwords. Stack. Initially, I will put mini-seek as num, and then I will try to show the seek. Then I will return self.mini-seek. Okay. Then what I should do is in the find show the seek method, the first thing I have to do is um if same passwords is so k to the power of n, which means that I've seen all the passwords. Passwords. Let me name it. Yeah. So if all passwords is seen, which it is the end of the recursive function, I mean the recursion. So if so I will update the miniseek, which is a global one. If yeah, this is met, I will update current seek when self.miniseek. Okay, current seek. Yeah, okay, good. So in this case, the current seek string, sorry, let me make it mini seek string just in case. Current sequence string is so first I will map the each current seek to char, then I will join it. So this is the current seek string. So many seek strings should be updated with this current seek string. And then I will return. Okay, so this is the case when all the passwords are seen, and otherwise I will choose one digit and then I will continue the recursion. So it should be I pick one number, then here I have to skip or just say continue if already seen. So let me see how I can create the password. Oh, so in this question, just in case, I will put same passwords as the set of integer. And when I get 0, 1, it should be 1. When I get 0, 0, it is represented as 0. Yeah, this is okay because the password length is exactly fixed as n, so it cannot include 0, 0, 0, and 0, 0 at the same time, which is converted into 0. Yeah. So, okay, what I do is current password is so because I choose default. So, and what I need to make sure is if the current seek is say 1210, and then I get D is 1, and assuming that N is 2 or maybe 3, what I need to do is I pick these three nums. Yeah, so 101 is the current password. But before that, what I'd like to make sure is if current seek is smaller than n minus 1, in that case, I cannot take any password. So I just have to continue the, you know, iteration. So what I should do is if length of the current seek is smaller than self dot n minus 1, or I should say, if current length is, yeah, in this case, current password is something I have to say. Otherwise, I don't have to think of the current password. So that being said, in line 71, I will start the current password with this. Then I move track backward, digit in current sig backward. Yeah. And I will pick k minus 1, n minus 1 digit. Let me do it in this way. So because I start with index 0, so I should do is, and in Python, this last index is represented as -1. So it should be minus I plus 1. Or I should say negative minus I minus 1. Okay, so if I is 0, it should be -1. If I is 1, it should be -2. Okay, so in this way, I can get the current password. Then, if current password is included in sim passwords, I can just ignore it. I can just continue. When I continue, it goes out of this if statement and also this if statement, and I go back to this, which is okay. And then I need to append this to sim passwords, and also I will append current digit to current seek. Then I will backtrack again. Then after that, I will roll back these changes. Okay, so that's it. Otherwise, I will just put this. So let me see. Actually, this is a bit annoying, so I decided to put it as a kind of, yeah, another condition in the, I mean, upper level of the financial district method. So what I like to do this time is so current seek isn't wrong enough. Then I will just push the, I can choose any number here. No. Then I push it to here, current seek, and then continues the, recursion, I mean backtracking, and then I will return. Okay, good. And otherwise, this is the condition I was seeing. Yeah, I will do the backtracking. Okay. Yeah, I'm pretty sure this is correct. So let me run my code. Okay, sorry. Lengths. Oh, sorry, and also I don't need this one. Find show the thick name current thick isn't okay. This should be yeah, instance field. Let me check other current six. Seems like it's okay. Okay, so maximum recursion depth exceeded. I just want to make sure that car theme passwords are, I mean, expanded. Hmm. Maybe this part is, yeah. Okay, let me write it. Yeah, let me write if theme passwords is expanded. I mean, becoming bigger and bigger. No, it's not getting bigger. Seems like, hmm. Oh, sorry, and also let me check. Theme password is empty and current sink is empty. Then theme password is 0. Is it okay? Then current sink is 0. And because, yeah. Oh, wait a minute. All passwords are C. Yeah. 00000. So maybe I can say what happening here is same password is always the same, but current six is expanding. My understanding is that if current seek, so in line 82, if current password is in serve the same passwords, then it will be, skipped. I mean, terminated. But it seems like it's not true in this case. Hmm. So let me take a look. Okay, so if current password is included in self-same passwords, okay, so this is okay, but if same password is zero, current password is zero, so which means that I have to continue. And in that case, I will choose, I don't choose zero, definitely. Ah, sorry, this should be IN in. Okay, so many six string, so this should be, yeah, instance field. Okay, good. Then let me uncomment the print statement. So I will run it again. Okay, so now I got time limit exceeded. Yeah, so tomorrow I will solve this question with the accepted optimized approach. But for today, let me finish with this. Okay, let me quickly wrap up. So this is a cracking the safe question, and I use the backtracking. And for this backtracking, I will put every possible integer in every step. However, there are two, I mean, kind of, yeah, sorry. And the terminal condition of this recursive function kind of backtracking is when all the passwords are found in the current sig, that's the end. I will update the global mini-sig string in this case. And otherwise, I keep backtracking. But one possible case I had to take care is that if the if I choose a digit and the last password, whose rank is n, is already seen somewhere else before, in that case, I don't pick that number. I cannot pick that digit. Yeah. If otherwise, it ends up with the infinite loop. So that's the case I have to finish and skip. Yeah, I mean, is that the digit I have to skip? And otherwise, I will keep going with chewing the digit, every possible digit, and do the backtracking. Okay, so that's it. Let me finish my today's coding practice with this. So see you tomorrow. Bye.